In this video, you will learn what is probability distribution, what is the process of preparing a probability distribution table and a graph, and how do we find expected value or variance. So let's do the basic thing first. What is probability distribution? So as the name suggests, probability is distributed. That means we know that total probability is 1 for any uh, events, all possible outcomes. And how do we distribute this 1? That is about probability distribution. Let's take an example of probability distribution and we'll understand that. Okay. Suppose a coin is tossed twice. Okay. So the first toss is either head or tail. Right? The probability of head is half, probability of tail is half. Second toss, again we can get a head or a tail. Probabilities are also half in this case. So half and half, head and tail. Now for probability distribution, we always look for a variable. Okay. So in this example of two tosses of a coin, I'll take that the number of tails is our variable and we'll call it x. Usually it is called x. Okay. Is a number of tails. So now what will we do? We'll make a table, probability distribution table. So it will be like this. We'll write here number of tails x. Okay. And here we'll write probability of that x. So how many tails we can get when we toss a coin twice? No tail, right? We can get one of them as tail or both of them as tail. These are the only three options possible when we toss two coin twice. So what is the probability that there is no tail? 0. So look at this branch. In this branch you will see that there is no tail, only heads. Both of them are heads. So half times half, that is the probability of not having a tail. So 1/4 is the tail of not getting a tail. Now we want one tail, right? So one tail is this branch or this branch. There are two branches, right? So this branch, the first branch will be half multiplied by half, which is this half multiplied by this half, which is 1/4. Or we'll have this half multiplied by this half, again 1/4. So 1/4 plus 1/4 will be half. The probability of getting one tail, exactly one tail, is half. And two tails, this is the branch where we have both the tails, this branch. So getting two tails when we toss a coin twice is 1/4. And if you add these now, 1/4 plus half plus 1/4, it will always be 1. That's why I said one probability of 1 is distributed in according to this table. And this is called probability distribution table, the one we just prepared. Okay, let's show the graph, probability distribution graph. Next is probability distribution graph of the same event, and x is number of tails. So now I have a graph, you can see here, where the x-axis, this x-axis, which is our variable, is number of tails, and this vertical one is the probability. I have drawn up to 1, which will not be needed, but still I have gone up to 1 to make it just a balanced looking graph. So 0 number of tails, the probability is 1/4. So we will draw a vertical line, just a line, okay, not a bar like a bar graph or histogram. That's it. This is what we need to show for probability of getting one tail, rather 0 tails. And now for one tail, it's half. The probability is half. So we will draw a vertical line up to the probability half. And then for number of tails equal to 2, we have another 1/4. And this is called probability distribution graph of number of tails when a coin is tossed twice. Let's move on to another example which is little different from this. Okay, so we roll a dice. We roll a die. Okay, if number is even, score is half. So if you get a 6, your score will be 3. Score will be halved. Now, if number, the outcome is odd, it is doubled. Yeah, and this will not be your regular rolling a die. So let's make a probability distribution table for this. All right. Before we're drawing the probability distribution table, we should know how many outcomes we can have. Yeah. So let's make a table like this. Okay. Let's reduce this line a little. Okay. So we will write outcome here and score here. All right. So if the outcome is 1, it will be doubled. Score will be 2. If the outcome is 2, it will be halved. If the outcome is 3, it will be doubled. If the outcome is 4, it will be halved. Outcome is 5, it will be doubled. And if the outcome is 6, we'll have a score of 3. So let's see what is the probability distribution table for this. So now we can have a score of 1, 2, 3, 6 and 10, right? We can have these scores possible with rolling a die. So we will write the variable x is the score, right? Score is 1, 2, 3, 6 and 10, right? These are the only possible outcomes possible. Now, how many times we're getting 1? 1, right? Out of how many? 1, 2, 3, 4, 5, 6. Probability of getting 1 score is 1/6. Okay, getting a 2 is twice here and here. So it will be 2/6, which is 1/3. Row 1/3. The probability will be 1/3. Okay, getting a 3 is 1/6 again. Getting a 6 is 1/6 again, and getting a 10 is 1/6. This is probability distribution table. And now let's make a probability distribution graph for this. And here is the probability distribution graph. This is probability. This scale, vertical scale, is probability, and this horizontal axis is score, which is x. And we can see that whatever was the probability, 1/6 for 1, it is 1/6 for all 4 of them, 1, 3, 6 and 10. But it's 2/6, which is half, rather 1/3. 2/6 is 1/3, it is for a score of 2. And this is how we interpret a table into a graph. Next thing we should know is expected value, which is called ES. What is the expected value of x, which is nothing but the mean value of, if we try to get a score, what will be the mean value if we try say 5 times, 10 times, 20 times. Expected value, the formula for expected value is sigma x px. So x is this and px is the probability of x. If you multiply both, we get x px. So whenever we want to find expected value, we draw another row to the table. And let's write x and px here. So we'll multiply which is x and what is px. We'll multiply them and we'll write here. So 1 times 1/6 is 1/6. 2 times 1/3 is 2/3. 3 times 1/6 will be 3/6, which is half. 6 times 1/6 is 1, and 10 times 1/6 will be 10 over 6, which is 5 over 3. And your expected value will be the sum of sigma. Sigma means sum of all of them, x, p, x. So this plus this plus this, you add all of them. If we add all the probabilities, we know that we get the sum as 1, right? But when we add expected value, we can get any number, more than 1, less than 1, depending on the outcomes. So expected value in this case will be the sum of all of these, and let's see what is it. And I got it 4, which means when you will roll such a die, when your scores are halved and doubled based on their odd and even, you will, on average, your score will be 4. If you do many times, your score is expected to be 4. This is one of the parameters after we draw probability distribution table and graph. The second parameter is variance. It's called variance of x. What is the variance? And the formula for variance is sigma x square times px minus the square of the mean expected value we got earlier. This is the formula. We also have divided by sigma px, but we know sigma px, the probability of x, and add all the probabilities. We know this is equal to 1. That's why we ignore the denominator. We just focus on sigma x square dot px minus this. So for finding sigma x square px, I need to copy the original table again. So here is my table again. So now I need to add another row. I like to add rows rather than straight away writing it in formula. Okay, so x square px will be a new row. So we will square the x first. So 1 square is 1, multiplied by 1/6 will be 1/6. All right. 2 square is 4, multiplied by its probability is 4/3. 3 square is 9, multiplied by 1/6 will be 9/6. 6 square is 36 divided by 6. Let's leave it like this. Let's not simplify. It will help to add this up. 10 square is 100 divided by 6. 100 multiplied by 1/6 gives us 100 divided by 6. That's what x square px is. So now we will add all. Let me also make it 8 over 6 so that all of them have denominator 6. Okay. So if I add 1 plus 8, 9, 18, 54, 154 over 6, that is x square, sigma x square px, and now we'll subtract the expected value square because we have to square it. 4 was the expected value, right? So square it. So now we can answer it. This is 25.6 minus 16. So 9.6 is the variance of this distribution. So now you are aware of what is probability distribution, how its table is prepared, how the graph is drawn, and how do we calculate expected value and variance. In this example, they're saying that the random variable x takes the values -2, 0, and 4 only. So we'll make a distribution table for this. -2, 0, and 4 only. Alright. Probability of -2 is 2p. Probability of x equal to 0 is p, and probability of x equal to 4 is 3p. What is p? That's the first part says. So we know that the sum of all the probabilities is 1. So if I add this, and this, we get 1. So following that rule, it will be 2p plus p, 3p plus 3p, 6p equal to 1, and that gives us p equal to 1 over 6. Now, they are saying find Ex and variance of x. So, for finding that, we should add a row, rather two rows under this. So, let's focus on Ex first, which is expected value. So, we'll write xpx here. Okay. So, where we multiply the x with its probability. Now, x is minus 2 in this case, and 2p, 2 times 1/6, that is 2p, right? Which is 1/3. So, basically, it's not 2p anymore. We can consider this as 1/3. So, minus 2 multiplied by 1/3 is minus 2/3. 0 multiplied by anything is 0, though it is 1/6, yeah? 3p means 3 times 1/6, and that will be half. So this is half here. So 4 multiplied by half is 2. So what will be the expected value, which will be sigma x px? That means add this plus this plus this. So 2 plus minus 2 over 3 will be 4 over 3. This is Ex. Now, for variance of x, we'll add another row under this. So let's do it. It will be x squared and px. That will be the new row. So we'll square x, which is minus 2, which will become 4. 4 multiplied by 1/3 will be 4/3. Again, 0 square will be 0, and multiplied by anything is 0. This one will be 16. 4 square is 16 multiplied by the probability is half. 16 times half is 8. So variance, which is sigma x square px minus the square of expected value or mean. Okay. So sigma x square px will be the sum of these three, which will be 4 over 3 plus 8. And minus, we got expected value as 4 over 3. So 4 over 3 square. So 28 over 3 minus 16 over 9. And that will be 68 over 9. In decimals, it will be 7.56. In this example, they are saying there is a fair cubical die. That means the probability of all the outcomes is equal. It is thrown and the area of a square of the side is calculated. Okay, and if the outcome, let's say outcome is something, the area is square of whatever number comes. So if the outcome is 1, the area will be 1. Though geometrically it will be same, right, for all, but that's what they're saying. They call it A. And 4 is 16. All right. So these are the areas possible. Draw up a table to show the probability distribution of A. So we have just these 4 outcomes possible. Yes. So let's make a probability distribution table for this. So if A is 1 or 4 or 9 or 16, what will be the probability of A? So 1 is being achieved when outcome is 1. So it is 3 out of 6. So the probability of A equal to 1 is half, 3 out of 6. Probability 4 will be only 1. Yeah, because 2, 3, 4, all 3 are same. So 1/6, 1/6, and 1/6. If we add all 4 of them, it should be equal to 1. All right. Now the question is, find the expected value of A. Expected value of A will be sigma A PA, and which will be, let's do it here, 1 multiplied by half plus 4 multiplied by 1/6. I'm not adding a row this time, I'm just writing it this way. 9 1/6 and 16 1/6. Okay, so what will that give us? Okay, let's go to 3/6. Okay, so 3/6 we can write half as 3/6, right? Plus 4/6 plus 9/6 plus 16 6. 16 plus 9 is 25, 29, 32 over 6. Or if you want to write in decimals, it will be 5 point, how much? 3, 3. All right. Let's talk about variance. Variance of A will be sigma A square PA minus expected value of A square. So expected value we already know, so let's write it first. 32 over 6. All right, let's write A square PA. So we'll have to look at the table again. A is 1 square is 1. Yeah, okay. So it is already squared, but we have to square it once more. So 1 multiplied by half, then the second score was 4. Yeah, 4, 9, and 16. 4 square 1/6 plus 9 square 1/6 plus 16 square 1/6. Put this in your calculator and you'll get the variance. What I got was 30.9. This video is about the binomial probability distribution. The normal probability distribution is when we do not take any success or failure into account. We just count the number of probabilities and add them, the sum should be 1. In binomial probability distribution, there are 4 conditions. Let's list them one by one. Number 1, there should be a probability of a success and failure only. There should not be a third option. There should be a success and a failure based on a criteria. Okay. Secondly, that probability of success must remain constant. That is, no matter how much big or small sample we take, the probability must remain same for all the selections. Number 3, there should be finite number of selections or trials. So 6 trials, 10 trials, 15 trials, fixed. There should be finite number of trials. And number 4, all trials or all events must be independent. These are the 4 conditions. If your question fulfills these 4 conditions, you can apply binomial probability distribution. So let's take an example. We go to a city, and by our experience of past, we know that the 38% of the people are left-handed. That means if I take a sample of any number of people, 30 or 38% of them are supposedly to be left-handed. Now that means 62%, remaining 62% of the people will be right-handed. These are the only 2 possibilities, because we have just 2 options, left-handed and right-handed. We don't have a third hand. So first criteria met, that was success. Let's call this success, and let's call this failure. Second, probability must remain constant. So if I choose 10 people of that population or 100 people, there is always 38% chance that the person we will be choosing will be a left-handed. So second condition is also met, that the probability is constant, is same throughout. Third, it is not in our hands, but if they have given finite number of selections, if we select 20 people out of the population, 20 people, Isn't 20 a finite number? So 20 people will be a finite number. That's why the third condition is also met. And fourth of them, if I select one person and then select the second person, there is no effect of the first person, whether he's left-handed or right-handed, on the second person. So all the events are independent. Selection of all people is independent, and that's why all four conditions are met in this. All right. Now let's form a question out of this. Question is, if I select 10 people, what is the probability that at least 2 are left-handed? Since we already know that all four conditions are met, that means we can apply binomial probability distribution. Now, how the binomial probability distribution is calculated, how the table is formed. Okay, let me do a demonstration here. So, if you remember, we had a binomial expansion of a bracket in earlier classes. It was like this: NC0, we started with 0 and we gave the first content of the binomial as same exponent as this number and multiplied b by the rest of it. So the sum of this number and this number should be the exponent. Second term becomes nc1 a to the power 1 and b to the power n minus 1. That means the exponent of a went up by 1 and exponent of b went down by 1 and so on till we reach this particular exponent reaches n. We write all the terms like that. Similarly, this was called binomial expansion, right? So similarly, in binomial probability distribution, we use the same expression here, this one, for distribution. The formula is NCR PR Q N minus R. This is the expression for one probability. So let me introduce what each one means. N means total number of selections. In the example I've taken 10 people. So in this case it is 10. Right? Finite number of selections. R, number of successes. So in this case we want at least 2, right? That's what we said. So our number of successes will be 2, 3, 4 till 10. Yes, all these are number of successes. Then P. P is the probability of success. In this case, 38% of the people are left-handed, so probability of success in this case becomes 0.38. Q is obviously probability of failure. In this case, it will be 1 minus 0.38, which is 0.62. So we have everything here. Now we need to make a probability distribution table for this, okay, which will be too much because there are 10 selections, so no problem. We can form it now. So our criteria of success is number of left-handed people. So the 10 people we selected, it's possible that 0 of them, none of them is left-handed. It's possible. It's also possible 1, 2, 3 and up to 10. Right? These are the only possibilities. These 11 possibilities are there. All right. So probability of x, if this is x, okay. Okay, probability of x. So let's write this one first. Our R, number of successes, is 0. So this becomes 10C0 and probability of success is 0.38, 0 and failure is 0.62 to the power 10. Always keep in mind this 0 plus this 10 should be equal to the total number of trials. And I will put this in a calculator later on, but let me write the second one for the time being. Let me write this one. Okay, N, which is 10, C1, success 0.38 to the power 1, failure 0.62 to the power 9. This is, and so on. We'll keep on writing like this. Let me write the last one. The last one will be 10, C10, and success 0.38. All 10 are success, means all people, 10 people are left-handed, and none is right-handed. 62, yes, 62. Okay, so now the question was, what is the probability that at least two of them are left-handed? That means this plus 4 plus 5 plus 6, 7, 8, 9, 10. All of them will be added to get that probability. And that becomes too complicated. How about this? If I know the sum of all the probabilities is 1, right? If I add all the probabilities, it will be 1. So I will just find these two probabilities, 0 and 1, which are excluded from our question, and will subtract it from 1. So 1 minus NC0, 10C0, 0.38 to the power 0, 0.62 to the power 10, plus 10C1, 0.38 to the power 1, 0.62 to the power 9, and if I subtract that from 1, I will get rest of them, which will become at least. So this is basically probability at least 2 left-handed. And I will put this in my calculator and I'll get the answer. Using the calculator, it came out to be 0.94. That is the probability that at least 2 of the people selected out of 10 will be left-handed. Sometimes no question, no word problem is given. They don't give any situation like we did here. There is no word problem. They will just write like this. X is a variable such that it has a binomial distribution, and say there is 10 here and comma 0.38 here. Obviously, B means binomial distribution. 10 means the total number of trials or events, and this is the probability of success. So in such case, they gives you different questions. Let me take one example, such an example. Okay, here it is. They have given this situation. V is a variable of binomial probability distribution where 8 number of trials are there and the probability of success is 2 over 7, right? They're saying find the probability of V greater than and equal to 7. Out of 8 trials, we want 7 or more successes. That means we mean 7 and 8 successes, right? P, number of P's should be 7 or 8, 2 of them. So let's write this one 7 successes first. So total number of trials are 8. We want 7 successes. Then probability of success is 2 over 7 to the power. This number should match with, the exponent should match with 7. The failure, if success P is 2 over 7, so Q, failure will be 1 minus 2 over 7, which is 5 over 7. So we will write 5 over 7 and exponent 1 here, because 7 plus 1 must be 8. Now let's talk about 8. It will be 8C8, successes 8, failures none. And just I will put these two in my calculator and I will get the answer. Let's take one more example. Same case, okay? Number of trials are 8 and the success is 2 over 7. Okay, now we want probability of successes between 3 and 6, 3 included. 6 is not included. That means they mean 3, 4 and 5. So we will write for 3 first. And then for 4, and then 5. These are mutually exclusive, that's why they are being added. They can't happen together, one of them will happen. So I'm writing it accordingly. So just add these 3 and you get your answer. So I hope it is understood that this is the common formula for all the binomial probability distributions, and only thing that is left now is the expected value and variance. So expected value and variance are the easiest part of binomial distribution. Okay, so the formula for expected value of a binomial probability distribution is NP, number of trials multiplied by the probability of success. The example we have taken in this one is number of trials was 8 multiplied by number of probability of number of successes 2/7. So the answer is 16/7 is the expected value of the question they gave us. Variance is NPQ formula. There is no need to draw any probability distribution table in this case for variance and expected value. Just apply the formula. So here it will be 8 times 2/7 and failure was 5/7. And 8 times 2 is 16 times 5, 80/49 is the variance. So if suppose you want to find standard deviation, it will be square root 80/49. So expected value, variance, standard deviation, formula, and 4 conditions all are known to you now. In this video, I will be explaining geometric probability distribution. It is an extension of binomial probability distribution. So let me remind you what were the 4 conditions for deciding to apply binomial probability distribution. First one was that there are only 2 options, success and failure. Second, there was a probability of success or failure was constant. Okay, there are finite number of trials or events. Okay, and then the events were independent. All selections, trials, events were independent. Okay, these are the 4 conditions. In geometric probability distribution, this condition is not there. There are not finite number of trials. You keep on failing. You fail, you fail, you fail, you keep on failing until you get a success. And then you stop. That means there are failures all over the sequences, but the last event is a successful event and you stop after that. Which means if there is a p x equal to 5, that means it means that the 5th time you are getting success, that means you're failing, failing 4 times, and then you're passing. So probability is the multiplication of probability of failures n-1 time, and then there's only one success and you stop after that. So let's take some example which will make it even clearer how do we do such questions. Okay, so this is an example where we have geometric probability distribution, and they have given an information x is a variable such that it has geometric probability distribution and the probability of success is 0.2. So P is 0.2, that means Q, the probability of failure, will be 1 minus 0.2, which is 0.8. The A part of this question says, what is probability of x equal to 7? Probability of x equal to 7. That means you are getting success in 7th attempt. That means you are failing 0.8 to the power 6 times you're failing, and the 7th time you're getting a success. So just put this in a calculator and you get the probability of x equal to 7. I'll do it together with other parts. Let's go to B part. They say probability that the success is not in 5th attempt. Probability that x is not in 5th attempt. That means it can be at 1st, 2nd, 3rd, 4th, and then 6th, 7th, 8th, and onwards. It can be any time but in 5th attempt. So in such case, whenever we have one particular attempt is excluded, that means we will subtract it from 1, as we know that the sum of all the probabilities of any probability distribution is 1. So we will subtract the case when it is a success in the 5th attempt. That means you will be failing for 4 attempts, and then you're getting success in 5th attempt, and that case you are excluding by subtracting from 1. Let's do the C part. In C part, they're saying you're getting success in more than 4th attempt. So probability x is more than 4. That means the success is coming after 4th attempt. That means it is for sure 4 times you are failing. And after that, which attempt you are passing, we don't know. So all of them, all the probabilities after that are eligible, and that is equal to 1, because it is 100% sure that after 4 failures you are getting success. It's not necessary which attempt you're getting a success, but we are sure that 4 times you're failing, and these 3 will give you answer. And when I used my calculator for all of them, I got these answers, and 0.4096. Let's take one more example. Here is the question where they're saying that it's a 5-sided fair spinner and the numbers are 1, 1, 2, 3, 4. Okay, it is spun until the first score of 1 is obtained. So 1 is your success, and other numbers are failures. So what is the probability of 1? Probability of 1 is 2 out of 5. Okay, that means probability of others, which is Q, will be 1 minus 2 over 5, which is 3 over 5. So this is P and this is Q. Alright, so find the probability that it is spun exactly twice. That means first, let's say A part, probability that, let's give it an alphabet x equal to 2. Exactly twice means P x equal to 2. It means we failed once, which is 3/5, and then we got a success 2/5. So the answer will be 3 times 2, 6 over 25. B part, at most 5 times. That means we get success at 5 times and below. That means we can write x is less than equal to 5. That means you are not failing all 5 times. That's what it means. When x is less than equal to 5, that means you're not failing in those 5 times. You're getting success somewhere in attempt 1, 2, 3, 4, or 5, somewhere. In that case, what do? We said we take the failures of 5 times and we subtract it from 1. So this Q5 will tell us that it is failing 5 times, but 1 minus will make it a success within first 5 times. So it will be 1 minus 3 over 5 to the power 5, and that will be 0.92. Okay, C part, at least 8 times. So probability is x is greater than or equal to 8. That means you fail for 7 times for sure, right? So that will give us q to the power 7, which is 3 over 5 to the power 7. We don't bother what happens after 7 failures. It can be success in 8th attempt, 9th, 10th, or maybe 100th. But we are sure that the attempt is failing 7 times, and that's why we write this. and this will be 0.028. So this is the summary that in geometric probability distribution, we fail for several number of times, but there is only one success at the end, and we stop after that success. If we want to find the expected value of x, in some books you will see it is 1 over p, that means the reciprocal of probability of success, or somewhere you'll get q over p. Okay, every book, every system had different formula for this, so I'm not going to emphasize more on this. You can see what your system tells about expected value. There is no formula for variance, so we will skip that. Let's talk about normal distribution. If you are here to watch a video on normal distribution, that means you have been taught about binomial distribution or geometric distribution of probability, or just simple probability distribution. You have learned these, and then now you have come up to normal distribution. Okay, what is normal distribution? The word normal in normal English, yes, general English. Normal means general. It means something which is natural. Yeah, that brings us to the reason that normal distribution is usually decided by nature. What I mean to say, suppose we take the distribution of heights of all the people in the world, and we draw a probability distribution table and then probability distribution graph for it. So we will see that very few people are short in height. There are people which are naturally at mean, there's a mean height of people, and there are people which are abnormally tall, right? Very few people. Can you see the height of probability? This is probability, okay? This axis is probability, this axis is height. So we can see that very few people have tall height, very few people are very short, but generally people, most of the people are. This shape of the probability distribution graph is called normal distribution. As I said, the normal distribution is usually natural. It's decided by the nature, but in some man-made situations also we can have normal distribution. But there are some man-made situations where we will have a skewed graph. Let's talk about skewed graph. Okay, let me draw a probability distribution graph for a factory and the annual income of the factory workers. So we will see that the most of the workers are working in the factory will have a certain income, but very few will have very high income. And this is not normal distribution. Normal distribution, if you look here, it's a very uniform kind of graph, but here you can see that the most of the incomes are on the left side and very few, like general manager or supervisor, or very few people have high salaries, and very few people will have low salaries, but most of them will be on the lower side of the spectrum. This kind of graph is called skewed graph, and the one which has a tail to the left right side at the higher scale is called a positively skewed graph. We can also have negatively skewed distribution graphs, which will be something like this, where the tail is at the lower data very few times. For example, if we see the departure time of any specific flight, so it is very rare that they fly before time. It is very rare, right? Normally they will fly on time or they will be delayed, right? But flying before time will not be good for the passengers who are late. But sometimes it happens that all the passengers are in, they are registered, and the flight leaves a little early. So that is very few times. That's why the probability there is very low, but mostly it will be on time or delayed. This is an example of negatively skewed probability distribution graph. If we take the normal distribution of heights of every major city of the world, we'll have normal distribution as I told you, but some of them will have graph which is higher, some of them will be wider graph, but they will have normal distribution. Okay, it's possible like this. But if we combine all of them, if we draw graphs of the means of the heights, if I suppose this is the mean, says this is 168 centimeter, the average height of the people. This one, say it is 172 centimeter, and this one is 151 centimeters. So if I take every city's average mean height and draw a distribution graph of those heights, it will again be a normal distribution graph. Maybe this is for Egypt, Cairo. Maybe this is for US, some city in US. Maybe this is for some city in Sri Lanka, right? But the overall graph will also be a normal distribution graph. That brings us to the next part, in which we'll talk about the properties of normal distribution graph. Okay, first of all, I've already told you the shape of normal distribution is like a bell. That's why it is called a bell curve. So it is a uniform curve from the center, and this center is nothing but mean. We denote it by mu. This is the mean of the graph. The lower than this, that means 50% of the data is below this. So if we want to find probability that x is less than or equal to mu, is 50%, or 0.5 is the probability. If I want to say probability x is greater than mu, is also 50%. Rest of the data is also 50%. That means the area under the curve below mean is 50%, above the mean is 50%. That is the first property of normal distribution graph. Another fact is, which is very interesting, if I take one standard deviation, so standard deviation is written as sigma. This symbol is called sigma. If we take one sigma away from the mean and one sigma below the mean, this is one sigma and this is one sigma, it is 100% sure, it is proved statistically that 68% of the data is in this middle two sigmas, one sigma above, one sigma below the mean. Okay, now if we go to second sigma, one more sigma and one sigma here, that means total are 4 sigmas, 2 sigma above and 2 sigma below the mean, 4 sigma. The percentage of the data, that means the probability of finding data here, is 95%. And if we take third sigma, that means 3 sigma below and 3 sigma above, the total probability is 99.7%. That means 0.15 is above positive 3 sigma and 0.15 is below negative 3 sigma. So that makes it 100%. Sum of all the probabilities in this normal distribution is 1, just like what we did in binomial and geometric distributions. One final information about normal distribution is that normal distribution is usually applied for continuous data. I hope you are aware of the difference between continuous and discrete data. For discrete data, we usually use other probability distributions like geometric, binomial. For continuous, we use normal distribution. For discretes, in some cases we can use normal distribution. We'll talk about in coming videos when we can use normal distribution for discrete data as well. That's all about the normal distribution of probability. Let's summarize and see you in next video. Welcome to the second part of the videos on normal probability distribution. In this video, we will know how do we use normal probability distribution and its graph to find different probabilities in mathematics. Let's start with the number one, which we talked about in video one also. In normal probability distribution, the middle peak is at mean, which is denoted by mu. So if we want to find the probability where x is a variable and it is less than equal to the mean, the probability is always 0.5. And in other words, it means that we are finding the area on the curve on the left side of the mean. Similarly, if we want to find the probability of x greater than mean, which is the right side of the mean, it will also be 50% or 0.5 probability. Number two fact is that we have three standard deviations on the right side of the mean. So this is one standard deviation, this is two standard deviation, and this is three standard deviation. Similarly, on the left side we have three standard deviation, and the distance between the two standard deviation, if we want to find the probability between these two, it is 68%. The difference between the two standard deviations on both sides is 95%, which is 0.95 probability. And if we want to find between three standard deviations on each side, it is 99.7% or 0.997 probability, and 0.15% is outside the three standard deviations. What if I want to find probability at a place where mean is not there, something related to standard deviation is there? So let me show you what I mean. Suppose this is one standard deviation here, and in this example, let's say the mean is 50 and standard deviation is 10, and this is 60, one standard deviation away from the mean. So mean is 50, okay, and this is 60. So I want to find the probability that x, the variable, is less than equal to 60. What it means is that I want to find the area under curve which is less than 60 here. This will be the probability sum of all the probabilities. So we know that the probability up to 50 is 0.5, right? Only challenge is to find this particular area, right? So if you remember, we said that in two standard deviations, middle standard deviation, the probability is 68%. That means half of this is 34 and half of this is 34. That makes it 68%. So that means probability of x is less than equal to 60 will make it 50 up to mean, and 34, it is on the right side of the mean, 34. So total becomes 84%, or probability will be 0.84. Let's take another example. Suppose I have another situation here. In the same case, the mean is 50 and I want the probability here. This is two standard deviations. So this is one standard deviation, this is two standard deviation. And since the standard deviation is 10, we said, so this will be 40, this will be 30, right? So 10, one standard deviation, another 10, two standard deviations. So if I want a probability x is less than equal to 30, we mean to say that find the area of this small part. All right. So we know that the first standard deviation has 34%. Second will have how much? Total is 95. The four standard deviations, let me tell you again, this is 2 up and 2 down. We learned that from here to here it's 95%. Yes or no? So the half of it, which is this one, will be 47.5%, right? From here till here. And total is 50% below mean. So that means this small area will be 50 minus 47.5, which is 2.5%, or the probability will be 0.02. This is a normal distribution curve. The mean is say 150. Standard deviation is let's say 18. Okay, so I want to find at a random numbers. So this is a number which is 172. So if I say one standard deviation above 150, it will be 168. One standard deviation, two standard deviation above 150, it will be 186. So 172 is not anywhere. In this case, we have to adopt a new approach which is called z-score. So I'm introducing z-score to you now. So what is z-score? We know that 172 is between 168 and 186. That means this is mean, and 172 will be more than one standard deviation above mean, but less than two standard deviations. So how many standard deviations? To find that, we find the z-score, and z-score will be what is the difference between 150 and 172, which is 22. We divide it by the standard deviation, which is 18 in this case, and this becomes our z-score. In decimals, whatever it gives us 1.22. This is our z-score. So the formula for z-score is the x, whatever x is there, subtract the mean from it and divide by the standard deviation, and this is the formula to find z-score. So once we have got this 1.22, what do? Then we go to a table which is called normal distribution table, which looks like this. And our z-score is 1.22. Can you see here they written z here in this table? This is a universal table and it is provided to you in every exam. So 1.22, for that you go to 1.2 first. So this is 1.2 here, 1.2. So we want second digit 2 also. So 1.2 in this line, go to 0.02, which is here on top. If you see, let me change the color for you. This is 0.02. So wherever they're crossing here 0.8888. This is the probability related to z-score 1.22. In some cases, if it is 1.225, there is another column here, here additionally. And in that case, they will write 1, 2, 3, 4, up to 9. So since 1.22 is known to us, 0.8888, this 5 will be from this column, suppose it is 12. So 12 means add 12 to the last digit, 1, 2. Sorry, not the 0.8888. So add 1 to this, and whatever this gives us, it gives us 89, 0.89. Isn't it? So that's how we read a normal distribution table. And if we go back to our question which was there, so if x is 172 or less and we want this area, it is 0.8888. This is the probability. So you might have noticed by now, every time I gave you an example, I gave you less than sign. Every time it was less than. So in this case also, P of x is less than equal to 172 is 0.8888. So this normal distribution table, this always talks about less than equal to the given number, and we find the z-score accordingly. What if the x is less than mean? In that case, our z-score will be negative. But if you look at your table, normal distribution table, there is no negative z-score. Can you see? Look at the left column, this first column. There is no negative. In next part, we'll talk about the negative ones. Okay, here is an example where the mean is 200 and the standard deviation is 41. I want to find the probability that x, the variable, is less than 167. Okay, so if you notice, I've not written the equal mark here. So since normal distribution is for continuous data, so we write equal to or don't write it, doesn't make any difference. It makes a lot of difference when we use normal distribution for discrete data. So now onwards, I will use less than. Okay, so z for x is less than 167 will be the data itself, 167 minus mean over the standard deviation 41, and it comes out to be negative 0.805 almost. Okay, now there's a negative here, and if we go to our table, we see that there is nothing for negative. I have changed the table also so that we can take care of this adding stuff also. So we want to find for minus 0.805, but there is no negative. So what we do, we just focus on the positive part, and this will help us to find for negative. So 0.8 is here. 0.80 will be 0.788. The probability for 0.80 is 7881. Now the last digit 5 will be looked up here. This is 5, and in the same row 5 gives us 14. Yeah, it's 14 in same row. So we add 14 to the last two digits of the probability, and it becomes 0.7895. And now if we go back to our question, 0.7895, it is for a positive. It is for positive. Let's say probability z is less than 0.805 positive. So how is that going to help? Let's see. 0.805 positive will be equally distant from the mean. like this is for minus, okay, let me not write here, this let's say minus 0.805 was here, so positive 0.805 will be exactly on opposite side, a reflection of this basically at the same level. We want, our original question was to find this area, but now we will find this area which is a reflection of what we want, right? But this 0.7895 is the area below this one, this whole area till 0. That is 0.7895 probability. So to find it for this area, we will subtract from 1 because sum of the whole probabilities is 1. And if I do this, it will be 0.2105. That is the probability of this area, which is a reflection of the area we wanted. So whenever, this answer is 0.2105. So whenever we want to use a negative z-score, just take the positive z-score and subtract it from 1. That is the shortcut to find the related probability of a negative z-score. In next video, we will talk about how to use normal distribution for discrete data, that is fixed number of data. In this third part of the video on normal probability distribution, we'll learn how to apply it with the discrete data. The difference between discrete and continuous data is that continuous data is made up of all positive real numbers. That means if we say 6, next data could be 6.0001 or even less than that. That means there is no discontinuity in the data, and there are billions and millions of data between two whole numbers. But in discrete data, we just use whole numbers or natural numbers. Okay, whole numbers are 1, 2, 3, 4, and natural numbers are same but with 0. Okay, so this is the discrete data, and we can use normal distribution for these in some specific cases. And when I say specific cases, I mean the cases where we use binomial distribution. Let's have a recap of binomial distribution. In binomial distribution, we have 4 conditions. First condition is there should be fixed number of trials. Second condition, there should be only success and failure. Third condition, the probability is constant. Of each trial, the probability remains same. And fourth is that all trials or events are independent. So if I want to take an example that my success rate of having a strike in a bowling alley is 0.72, which means 72% of the times I hit a strike, means I knock down all 10 pins. So this becomes the probability of success, P. We call it P. Probability of failure, in that case, will be 1 minus 0.72, which is 0.28. We call it Q. So let's talk about a situation when I try to hit bowling pins 10 times. So fixed number of trials are there. My success and failure rate are 0.72 and 0.28, and probability remains constant every time, 0.72 and 0.28. Every time I try to hit the pins is independent of the previous attempt. So all 4 conditions are met. Suppose I want to know my probability that I hit all 10 pins or equal to 2. which means that I either have a strike 0 times, that means I don't hit any of the 10 attempts, all 10 panes, or once only and 9 times I fail, or 2 only, 8 times I fail, right? And then we interpret this into the mathematical expression. I had total 10 attempts, out of them 0 are success, and the probability of success is 0.72, so 0 powers to that, but the failures are all 10 times. And this is how we find out a binomial probability, and then I will similarly write one for once and one for twice, and I will add them. This was binomial distribution. In case the number of attempts are very high, say n is 75, so I try bowling alley 75 times, and I want to find the probability that my success is less than 24. Okay, and I want to use binomial distribution. But if you see, when I use x is less than 2, I wrote 3 terms. If I write x is less than 24, I will write 24 terms, which is a very big deal, and there is possibility of mistake. So what do we do? In such case, we can use normal distribution. If we use normal distribution for binomial situation, we call it normal approximation. So before we can approximate it normally, we need to test it. The test is this: NP, which is mean or expected value of a binomial situation. It should be greater than 5. Similarly, NQ, the total number of attempts multiplied by the probability of failure, should also be greater than 5. So let's test these two first, and then we can do normal approximation. So 75 multiplied by 0.72 will be NP, and that is 54, which is much more than 5. This is okay. Similarly, here 75 multiplied by 0.28, which is 21, also greater than 5. So we can carry out normal approximation for this situation. And to find that, for normal distribution, we need a mean, right? And we know mean now, it's 54. What about standard deviation? Standard deviation is square root of n, p, and q. This is what we learned in binomial distribution. So let's carry it out. 75 times 0.72 times 0.28 and square root it, which is 3.89. Now we have a mean, we have a standard deviation. Now our original question was probability of x is less than 24. Now if you remember, in normal distribution we said if we write probability x is less than equal to or less than some number, say 2.5, it's okay. You write less than or less than equal to, does not matter. But in discrete, we cannot have 24.89 or 23.85. So what do? We want to have less than 24. That means it should be probability of x is less than equal to 23. Isn't that clear? So to include 23, what do? We reduce 24 to 23.5 so that we are as close as to 23. And now we will use the same thing. Let me draw the normal distribution graph for this. The mean is 54. And I want somewhere here 23.5 and less than that. This is the probability I want. So I will first find the z-score. Z-score will be the data, which is 23.5 minus 54 over 3.89, which came out to be minus 7.84. Now, if we look at our table, normal function table, there is no minus 7 here. Can you see? Even positive 7 is not there. That means what we estimated here was well beyond this 3. That means minus 7.8 will be somewhere here. So there are 0% chance, or the probability is 0, that we will get a less than or equal to 23 successful attempts. The probability is 0 because it is well outside our normal distribution graph. Now let's take a real life past paper example to see where we will have some kind of answer, proper answer. Here is a real question, exam question example, where they're saying that the probability that New Year's Day is on Saturday is randomly chosen here is 1/7. We know that one day out of 7 days is a Saturday. 15 years are chosen randomly. First part says, find the probability that at least 3 of these years have New Year's Day on Saturday. So we know that there are 4 conditions for binomial which are met here. There are fixed number of attempts. There is a success, which is 1/7. There's a failure, which will be 1 minus 1/7, which is 6/7 is the probability of failure. Every year is independent, and the probability remains constant throughout. So we use a binomial distribution for this, and I wrote already what should we do first part, because this video is about normal distribution. So I just wrote it in advance to explain to you that from 100% probability, I subtracted the probability that none of the 15 years have a Saturday on the 1st January, and 1 year out of 15 and 2 years out of 15. They are removed, so it will become at least 3 of the years have first day as Saturday. So this was the answer of first one. Just put this in a calculator, you get the answer. But what I'm interested is in second part, where n becomes 56. And they want us to use a suitable approximation, and normal approximation is the suitable approximation here, to find the probability that more than 7 of these years have New Year Day on Saturday. So this is what we have to find. First, let's test if NP and NQ are greater than 5 or not. So let's do it. N is 56 times P is 1/7, so that comes out to be 8, which is greater than 5. Perfect. And 56 times 6/7, this will also cancel. 8 times 6, 48, which is also greater than 5. So both tests passed, so we can use normal approximation. So our mean is 8, we got it already. Standard deviation will be square root 56 times 1/7 times 6/7. So this comes out to be 8. Okay, 8 times 6, 48 over 7 square root equal to 2.62. So now they want a probability that x is greater than 7. That means 8 onwards, isn't it? So we can do what? We can write it like this. So let's draw the normal distribution graph. Mean is 8. They want greater than 7. That means we can take somewhere here 7.5, right? So 8 is greater than 7.5, so this is the area we want. Okay, so Z score will be 7.5 minus 8 over 2.62, which will be minus 0.19. So if it is a negative, we learned that for negative we write probability is equal to 1 minus whatever is the probability of x is less than 0.19. So let's go to 0.19 probability. Okay, 0.1 is here, 0.19 is 0.5753. Okay, so it will be 1 minus 0.5753, which is 0.4247. Okay, so this is the probability that it is less than, because we took less than, our normal function table is also for less than, so we got the less than, but they are saying greater than 7, so we need to find this area, isn't it? And which is back. If I do 1 minus 0.4247 again, I get 0.5753 back. This is how we carry out normal approximation of discrete data.